Hello, my name's Matt Tifo, and today I'd like to show you my Chaos-powered Harrier jet. So, first things first, we'll take a look at the engines. Using 4 Kerbal Aircraft Expansion jump jets attached to Infernal Robotics Rotatron servos so that they can vector front to back, just like the real Harrier. The rest of the plane's mostly built out of B9 aerospace parts, and some Kerbal Aircraft Expansion parts thrown in there as well. And it's powered by a Chaos processor. So this mod gives you a computer part that you can write code for that has access to all the vehicle's flight controls. Now this is all done using, actually I'm not even using raw control, I'm not even using the control surfaces. This is all done via controlling the engine thrust limiters. So there's 4 engines, and the code is balancing the thrust between all 4 in order to maintain pitch and roll stability as well as vertical velocity. And then wrapped around those controllers are forward and lateral stability as well as directional control around the yaw rate controller. You can see the rear engines vectoring there to provide directional control. Alright, so we've come up to altitude. Our aircraft state machine is switched into an airborne mode. The altitude controller is taken over from the vertical velocity controller, and now we're holding altitude. And I'm commanding the forward velocity controller to get up to a positive forward velocity. Setting it up to 10 meters per second ultimately. And you can see the aircraft tipping forward in order to accelerate. There it goes. Right up to 10 meters per second. So, next, as I start to change the directional controller set point, we're going to start to rotate the aircraft to the right. But because the lateral velocity controller set point is still at 0, you can see the aircraft starting to roll in order to bring the velocity vector right back off the nose so that we maintain a straight course as we turn. Well, straight on the new heading, I should say. Okay, well, I think I'm going to time accelerate a little bit now so that you guys don't have to sit through here. Obviously, we're heading over to the VAB where I'll show you what's going to happen next. Okay, and we're back. So, most people try and land on the roof of the VAB, and I'm certainly not going to knock this as it's rather difficult, especially in the stock game. You have to build your craft meticulously so that it's perfectly well balanced even as the fuel is draining. Well, that's better now in 1.0, but even still. And yeah, so just generally controlling a VTOL, unless you have a mod like throttle controlled avionics or whatnot installed, it's sort of a pain. Whereas, as you can see, I'm not really having too much trouble here. So rather than just doing a straight up landing on the roof, I figured I would show you actually the idea that even gave me that I had for this aircraft in the first place. Beside it just being a cool project, was that, with all these Kerbin surface survey contracts, it's sort of a pain when they suddenly randomly generate a waypoint for you to go visit that happens to be in the middle of like sheer cliffs or mountains or whatnot. It's like, well, how am I possibly supposed to land to get a surface sample? Well, with this, the answer is very simply, don't land. What we can get away with here is, well, you'll see in a moment. Just bring it down very, very gingerly. You can see the radar altimeter reading on the right-hand side. Sorry, left-hand side up in the corner. Third line from the top. Showing we're just about 21 centimeters, 12 centimeters off the, off the surface, but that's accounting for the landing gear height because that radar altitude value is also used for landing. So, we can extend our ladder here, and boom, EVA. So, you'll notice as I climb down the ladder, the force that I'm exerting is going to rock the nose out a little bit. You can see the rear engines there fighting to hold it stable. Now, for some reason, which I can't explain, my camera was locked at this point, and I could not rotate it to get a better view. But as you can see, my plane is not going anywhere. So, can take my time. Well, I would collect a sample, but instead here I'm just going to plant a flag. Yeah, the average drift rate on that aircraft, I think, is on the order of about 3 millimeters per second. Actually, and that tends to oscillate around 0, so really it actually tends not to go anywhere on average over. I haven't tested it over super long periods of time, but anyway. So now we've got the flag. Let's hope we can get back up. Well, I mean, I'm recording this in the past, so I know I succeeded, but it was kind of hairy. I didn't know if I was going to be able to get back up with the camera angles being all screwy, but no, there we are, back on board. And now I'm going to sort of time accelerate over so you can watch the landing. Okay, so this last little bit here is just sort of to demonstrate the precision of the speed controller. That's it killing about a meter per second of speed almost instantaneously. But anyway, we're basically going to try and land just smack in the middle of the pad. So this vehicle will very easily hold sort of increments of 0.1 meters per second, at least, especially below 1 meter per second. Above that, some of the steady state error starts to go up. Still some tuning improvements to be made. Anyway, also the servos can be a little bit glitchy. If your physics frames wind up taking a little bit longer than you anticipate, they can tweak out a little bit, which can, of course, cause crosstalk into other controllers. A little example of that coming up here. Whoop, you see that dip there? That is just sort of a coalescence of crosstalk. Anyway, I'm about to start the landing sequence. Of course, I do it while I am too low over the pad, so my gear doesn't have time to fully extend before I get down. But thankfully, the gear in KSP is very resilient and just lifts my whole craft back up. Anyway, thanks for watching. This has been the review of my Harrier. I've been working on this for months, so hope you enjoyed.